here are my tables of an f and a g function. And it says right here, what is the average rate of change of g from 1 to 3? So all I care about is g here, and I went from 1 to 3. So average rate of change is slope. So basically I'm trying to find the slope from 1 to 3. So the first thing you might want to do is write 1 to 3 as two coordinates. So the coordinate for 1 to 3, 1, isn't that 1.25? And isn't the other coordinate 3, 1? So the first thing for some of you might help to write this as 1.25 and 3, 1. Those are two coordinate, not intervals. Now, can you find the slope between those 2 points? Hopefully you can do slope. Slope is m equals y2 minus y1 over x2 minus x1. We're going to use that formula to find slope now. You might want to write that formula down if you don't have it memorized. And when I do that, I get m equals, it would be the y's, so it would be 1 minus 0.5 over 3 minus 1. Now, I don't want to deal with decimals, because you take a decimal and you're dividing by something is a little confusing for some. I'm going to change 0.25 to a quarter. Are we okay with that? You can leave it as decimals if you can do that, but are you okay 0.25 is a quarter? Quarter, 25 cents. So watch this. I'm going to do 1 minus a quarter over, what's 3 minus 1?
2.
2. Now, hopefully you realized in order to subtract fractions, don't you have to make this 4 over 4? 4 over 4 minus 1/4. Or just think of it. What's $1 minus a quarter? 75 cents, or 3/4. However you want to think of it, but understand, I would probably make that 4 over 4. 4 over 4 minus 1/4 is 3/4. In the end, hopefully you can understand, we now have 3/4 divided by 2. Now, I wrote it like this because, see how too many fraction bars? If I didn't write it like that? I have 3/4 divided by 2. I didn't, again, I changed it from this division bar to that because I'd have too many division bars and it could get confusing. Now, do you understand when you divide, you flip the second one and multiply? So when you divide by 2, aren't you really multiplying by 1/2? So this is really 3/4 times 1/2. And what does that give us? 3/8, which you could make it a decimal. Now, on the test, you could have fractions and decimals here. All right? And you probably won't have a calculator to deal with it. So if it does, you have to be able to deal with those and compute the average rate of change, or the slope. Which function has a greater average rate of change from 3 to 6? Now, could I find the slopes of both of them, from 3 to 6? Can I find the slopes of these two? Yeah. Could you also graph it and see which one's steepest? Yeah. But could you just look at the graphs? Look at the equations. From 3 to 6, isn't it from here to here? Which one changes the most? Does 25 to 0.25 or 1 to 8, which is a greater change? Is that pretty obvious? Isn't 250 to 0.25 a way bigger change than 1 to 8? Even though it's in the negative direction, does that matter? No, negatives just tell you direction. It's still way bigger change. So is everybody okay? F of x? Is it? And my description, my reasoning would be, it has a larger change. It has more change. Has a larger change than g of x. Questions on that? Last one. On which interval does g of x have the smallest average rate of change? So here key is smallest, and this is saying g of x. So you got to look one by one on g of x. Where do you have the smallest change? Now, At first glance, does it look between 1 and 3? But here's what's kind of weird, is you have to pay close attention. You actually have to do the slopes for each of these. Because look at the change here. Isn't that a change of 2? Isn't that a change of 3? Isn't that a change of 4? Each one has a different x change, so you can't technically just look at the y changes here. Because the changes in the x's are also changing. So watch what happens. The slope for the first one is going to be 1 minus, oh actually we did it already. Didn't we do it right here? For the first one it's 1 minus 0.25 over 3 minus 1, which we did that. That's 3 over 8. That's kind of nice. The next one, isn't it going to be, what is it? 8 minus 1 over 6 minus 3. We take this minus this over this minus this. And when we calculate that, we get 7 over 3. So far, which is smaller? 3/8 or 7/3? 3/8. So this is the last one. I'm going to do, for the last one, I'm going to do 1/28 minus 8 over 10 minus 6. So 120 over 4. Is that pretty obviously bigger than 3/8? So was it really necessary to check this? No. I mean, yes, this was the smallest. But what if the changes, you got to be careful because sometimes we can make these so that you think it is this one and it could be another one due to how the x's are changing. So my answer for this one is my interval 1 to 3. This is the smallest of all 3 changes. Be very careful. You can't just look at these. You have to also compare and find the slopes on that one. If you had the graph, it'd be even easier.